Hello, everybody. Thank you for having me. We are going to have the presentation with the most cliche title, Taming the Beast. I'm sorry, marketing put me up to that. But apart from just sprinkling random pictures of wild animals, I do have a plan. I am going to talk a tiny bit about Varnish, a tiny bit about me. This is an ego thing. I'm French, so cannot be avoided. We will be explaining what we mean with HTTP reverse proxy, why they are cool, why they are bad, and how we can get the cool without the bad. And hopefully we will have questions and maybe even answers. So, tiny bit about me. I am not an SRE. I know, sorry for the lies, deception. I'm a developer. I have been for about 15, 20 years now. I'm a solution engineer, pre-sales, support engineer, so I help SRE solve their problems. I'm a C developer and I use Arch, so that tells you that I like the pain. I do not use Gen 2 or C++, so I'm not a maniac, so there's that. Okay, a tiny bit about Varnish. So this is an old school open source project to tell you how old school. It started in 2006. Our chief architect is a FreeBSD kernel developer, and the developer meet weekly on IRC. Doesn't get more old school than that. Varnish Software builds an open core enterprise product on top of this. We started as a caching engine to replace Squid. Did a great job at that, but apparently Squid is still around, so maybe not that great of a job. But yeah, we've grown in terms of features. We will explore some of them. I'm not going to focus too much on caching here. We are going to have the question of what do you think, what do you do differently from Nginx? Plenty of things. I do not really have any love for Nginx, but they are fine. But we do things differently in the sense that the configuration gives you total control by basically giving you a programming language rather than just some knobs and switches that you can flick. And I know I'm a corporate shill, but I honestly think that we have the best logging system ever. Also, because I do not want to see you on IRC, there's a QR code to Discord. Join us. I will personally greet you with an animated emoji, as is customary on Discord. So what do we mean when we say HTTP reverse proxies? This is going to be broad strokes, HTTP 0.9. If you're still using that, please stop. Up to quick, aka HTTP 3. When we hear about level 7 load balancer, that's probably HTTP reverse proxy, Kubernetes ingresses, gateways, or whatever the name is this week. That's going to be us. Reverse proxies, I'm going to consider the systems as a general entity, so that can be one server, that can be one container, that can be a cluster or a massive service like a CDN. And I'm also counting your microservices that you hastily written in Node.js, Go. It doesn't really matter. What matters is those services, those systems are going to grab an HTTP request when sent by a client, and to provide a response, they are going to turn to the origin or the backends. Semantics are not that important. And send 0 or more HTTP requests, grab the responses. That can be for content composition, that can be for retrying because you didn't like the initial response, etc., etc. Everything's going to count. I'm going to be extremely generic here. I do not necessarily like the OSI model or the TCP IP model, so I rolled out my own with Blackjack and Whiskey. We do not really care about the lower levels, Ethernet, Aloha, cables. What we care about is the stuff that we can see when we are logged onto a machine. So at the bottom, in red, the stuff that we cannot touch. TCP IP at the top, the green stuff is the good thing. All those protocols are going to be built on a random wild animal. I'm doing my job. The green stuff is APIs, video, storage, DNS. I don't really care. Usually they are going to be a tiny layer on top of HTTP. And HTTP is pretty cool. In truth, it's absolutely terrible, but it's a simple request response protocol. It's mainly text-based, even though, yeah, I know HTTP2, HTTP3, yada, yada. But it's easy to reason about. People have been familiar with it for like now 3 decades. And pretty much every language under the sun, apart from C, but yeah, leave C alone, is going to allow you to build a HTTP reverse proxy in a matter of minutes. Notably, Go and Node are going to make that super, super easy. So they count. You do not necessarily need HA proxy or Varnish or Nginx. You can roll out your own. You don't have to, but you can. Because we are going to sit at halfway up the TCP/IP layer and up to halfway the green layer, we can do a bunch of stuff. Basically wrap your really old APIs, for example, and put TLS on top of it, or rate limiting, or compression. You can do connection pooling. You can do request collapsing. If you want to do OpenTelemetry on top of a legacy system that doesn't support it, put an HTTP reverse proxy on top of it. It will do the job. I'm going to give you a couple of examples, of course, based on Varnish. You can do that on pretty much every system, but I didn't spend 12 years hacking on this thing to just shut up about it. So a few examples. You have some storage. For some reason, the people who put the text stuff didn't compress it. Varnish can compress it on the fly before putting it in the cache so that you save some memory or disk while caching, and also some CPU, because most likely the clients are going to support compression. As I told you, Varnish supports a programming language called VCL. Here, basically, we are going to act on the backend response as soon as we receive the response headers. Another example, if you're doing APIs and you want IPs to be limited to 15 requests per 10 seconds, well, that's pretty easy to do. You just import a module like you would a library in any language, and basically ask, hey, is that thing denied? And if it is, then you just generate a 429 response. And if you want to test something in staging, which would be weird, we usually test in prod, but I don't know, and you need to rewrite some links in HTML, you can do that with regular expression substitution. So what is there to dislike? Plenty of things, but so that you believe me, I'm going to use support cases or discussions I've had with customers. The names have been changed to protect people, and I'm going to also fast track the investigation, because we do not have like 5 days. And I'm also going to, for your ears, reduce the number of expletives I may have used when answering those people. But first, I need to remind you that networking is like an onion. It has layers. The ability to make you cry. Correct. Mostly, if you want to go to the red stuff, and you may think that Guillaume is weird, he changed the colors. The green stuff is the stuff that everybody agrees on, and it works. The higher up you go, the redder it is, and the messier it gets. But the important part is that if you want to go to the upper layers, you need to go through the lower ones. With that being said, I know this is a lot of code. I'm sorry, and it's not YAML, but I believe in you, because you were there for the C slides yesterday, and you did great. So bear with me. This is a VCL that is going to define an ACL list called local purgers. The VCL receive subroutine is going to be called whenever we receive HTTP headers for a request. We check the method. If it's purge, then we check if the client IP matches local purgers. If it does, we purge. Otherwise, we tell the client to walk. Everybody okay with that? Yay, cool. Tough. Okay. If that seems sensible, yeah, it does. Problem. If you have an HTTP reverse proxy in front of it, it is going to make a request to you using the local part of the NIC. And therefore, anything that goes through that HTTP reverse proxy is going to be authorized to purge. It may be what you want, but usually that Nginx is in front or is standing like on the open internet, and it's going to mess you up. This is one of the cases where I cannot blame Nginx. It did nothing wrong, so it's fine. It's easy to fix. You tell Nginx to put the actual client IP into a header, and then you tell Varnish to convert that header into an IP, because we have types in VCL. We are not animals. Taming the beast, animals. I'm really leaning on that one. And then we check against local purgers. Second one, I get that every 4, maybe 6 weeks. Can you cache transparently YouTube, Facebook, Netflix? So show of hands, who think we can? Who think we can't? Who thinks it's a toss-up, a trick question, the Frenchman is out to get you? Well, okay, that's fair. Yeah. The answer is no, we cannot. We cannot do that transparently. Maybe we can, but remember, to get to the HTTP stuff that will allow you to see what is actually happening, and so that you can cache, you need to go through the lower layers, including TLS. And can you convince people that you are youtube.com? If you do not have the certificate chain, it's probably going to amount to you going to the PE teacher, and my mom said I don't have to go to PE. And the teacher is going to, yeah, you signed that yourself. So no, we can't. And this is something that we need to realize, because we have layers one way, but we have also layers the other way. Tools are going to lie to you. It's never just an HTTP request. It's always a series of requests. And I'm picking on curl, for example, here, because the 3 commands that you are seeing here are going to do 3 different things. Slightly different, but still different. This is left as an exercise to the audience. We can talk about that during the questions, but all the tools are going to do that. Go, for example, has that host field, which is actually just a header, but it's treated a tiny bit differently, because even though it's a header, it's a bit special. And we have abstractions open on top of abstractions. They're all leaky, they're all terrible, and HTTP across like 40 years now has been pretty bad at separating data, logic, and we need to deal with legacy implementation anyway, so it's super hard. Who has ever debugged REST APIs? Yay, cool. So you've had that discussion. Hey, bro, that endpoint is broken. No, man, the logs are fine. My guy, I'm telling you, it is broken. I checked, I also checked. And then you look at this, and you have a HTTP 200, and the JSON is saying error. You are both right. But you haven't defined which level you wanted to play on. And I am not going to go into that one, whether the REST APIs should use HTTP status code, because we could also do Vim versus Emacs or tabs versus spaces. Just, discuss it, decide, but yeah, make the clear distinction. Context is going to be important. The last one, my favorite, is going to be a real use case that we had where the customer was saying, hey, we put Varnish and now we have customers or users on the intranet complaining that we have this crap. This is not the website. This is a dramatization. But essentially, some users were getting that, that weird error message. And I mean, I cannot say it's not Varnish. There's literally Varnish cache server in there. So that's us. But we look at the log, and basically F5 is not replying to us. We connect to it, we send a request, and F5 just leaves us hanging. Problem, we have the logs saying that, but F5, which has been here for years, doesn't have any logs. That's annoying. We have a look at the Varnish logs, and oh, that red is terrible. I'm sorry. And we notice a pattern. BREC account is basically telling you how many bytes we sent for headers, body, the sum of both, and how many we received for header, body, and the sum of both. The top 3 requests are fine. The bottom are bad. There seems to be a limit around roughly 4096 bytes, also called 4K bytes. We asked the BIP team, are you, by any chance, dropping connections if you receive too many header bytes? Yeah, we do that. Cool. If we didn't have the logs, that would have been a mystery because F5 didn't tell us anything. The funny thing is that they are breaking the lower level TCP/IP because of what they're receiving on top. So that's always fun. Varnish's fault was timing out and trying to send an actual response to the browser because they already had the problem when Varnish wasn't there. It's just that the browser never got the response, so it never created that tiny square. So that was really just, Varnish's fault was just pointing out the issue. So it's always fun. It will come back later in the talk. Okay, so how do we deal with the pointy bits? Reminder, I am not an SRE. I help SRE, so I'm just going to make a tiny detour on how we handle support at Varnish. Unless there is something like massively critical, we usually deal with things asynchronously on Zendesk, Slack. We are going to go into war rooms, but we do not have direct access to the machines. At most, it's a screen share with the SREs. Also, as I'm sure you all know, you may not be the ones affected by the issue. You just have somebody yelling at you that there's a problem and you need to fix it. So we are one more step removed from the problem. So we need good tooling. And one solution, this hasn't anything to do with HTTP reverse proxies, but I think this is a good call out. We use Varnish Gather, which despite the name is actually fairly generic. This is a shell script that you can find on Google, QR code over there, that is just going to run a couple of hundreds of commands to tell us or dump the state of the machine, tell us everything we can glean, trying to be conscious of privacy issues, of course. Possibly send that to a file bin so that the support engineers can have an offline look at the machine without disturbing and without doing many back and forth with the SREs. It's been a great tool that has massively reduced the amount of time we spend dealing with bugs. Gotchas and pitfalls are also automatically detected by a secondary tool that we can use to process this. Use it. You probably have dashboards, alerts, and all that, but do you have everything that is in that gather? I honestly, I doubt it because there's an immense amount of data that you are able to condense on just a few seconds of shell scripts. So what was the question again? Oh, the sharp bits. How do we deal with them? So the first slide, I'm sorry to be that guy. The actual answer is, well, the first answer is git good. And I know, I'm an ass. I'm not the one on the front line. But at the same time, because we are always focused on Varnish and we have that singular focus, we need to be hyper aware of everything that could go wrong going in or going out. And when a customer ticket starts with, my web page doesn't work, that's not really useful. We always want to try and drill down, okay, what object in the page doesn't work, which transfer failed, and trying to drill down really on the specific reproducer that we can build. You do not have to know all the protocols. You do not have to be able to spell out the frame structure for all of them. Just know they exist. I mean, we have Google, we have ChatGPT. Use them. But for each of the protocols, there is a tool that will tell you, hey, that part works, that part doesn't. Personal preference, dealing with HTTP, curl-v is going to be an amazing tool. Whatever people say about curl, it's antiquated, it's bad, and all that. Remember, I use C, so I may be biased. But curl-v is going to tell you everything it does, DNS, TLS, and the -- connect to that I realize that not a lot of people know about will allow you to force DNS resolution to a specific IP. That means you can send a request to a specific IP without using the dreaded -k that is going to, bias your TLS analysis. The second one, and I told you I was in love with the way we do logging. Varnish logs everything, but doesn't do anything with it. That sounds weird. But basically, what Varnish does, it logs into a circular buffer in memory and lets other tools read from it and extract whatever information they want and format that. So the maximum amount of information that we can get looks like this. It's not so much a report of the request and response. It's more an event journal. Hey, I received this at this timestamp. The method was this. There was those headers, but I also entered this specific subroutine in the VCL, and that subroutine modified the header this way and the other one this way. So you have an enormous amount of information. When we have a Varnish gather, we are going to get a few hundred megabytes of the last few messages. And you have client requests, you also have backend requests. And we are going to tell you all about that. For debugging, this is what we want, because this is instant, it has the most amount of data. Varnish log is the tool for us developers when we try to find out an issue. That's probably way too much information for you if you're trying to aggregate those logs into an observability platform. Good thing, we have Varnish log JSON that's just going to build a JSON report of the stuff that went out, that came in without the intermediate steps. Sorry, did I mention I'm French? Sometimes it's just, it gets out tiny bits. Sorry about that. So yeah, JSON is a horrible format, but everybody speaks it, therefore it's a good format. On the bandwagon we go. Varnish and CSA is going to grab the exact same information as the other two, but it's just going to build usually a one-liner. Who remember NCSA, Apache? Okay, cool. A lot of young kids then, cool. But yeah, if you want to build messages or lines that are like super well defined and you know what you want, for example, billing, accounting, compliance, cool, that's your tool. And while it's not exactly a log, I am going to argue that metrics are going to basically tell the same story. In this case, we had a client request. It was not a 400 or 4xx response, and it also triggered a backend request. But same story told 4 different times, 4 different ways, depending on what you need, and that's really the point. You probably do not need to log everything all the time forever. There is sampling. You may store data on disk, for example, for a day or for a week. And if everything's fine, just remove them. Billing, you probably want to keep that for a longer time. The JSON stuff, maybe a couple of months if you need to really go back and debug, for example. But the one thing I really want to point out, it's okay to store stuff multiple times. As engineers, our instinct is, oh no, I just want to grab everything and keep it forever because that way I will always have the data. You just built yourself a huge haystack and it's going to take ages to go through it. So be more targeted, and if there is overlap, this is fine. In time, the overlap is going to decay and you'll be fine. And one thing I haven't seen a lot of tools do is Varnish is great because it's going to tell you about the stuff that happens in front and in the back. So every time you have one HTTP request from a client, you usually have 2 HTTP transactions. You're probably going to tell me, but Guillaume, I don't really care about the backend side because I can ask the origin about its logs and I can reconstruct the story. Were you paying attention when I was talking about F5? Sure, if both sides agree, there is redundancy. If they don't, guess who gets blamed? Us. And in general, and you probably see where this is going with the vibe of the conference, one client request to the service in general is probably going to explode into a myriad of other HTTP transactions, which is why tracing is cool. If you were there yesterday for Chris Detsika's excellent talk, he did all the groundwork, so I do not need to repeat much of what he said, but you have a huge advantage over us at Varnish, where we have those blinders where we can only look at Varnish and we can only infer what's around us. Chances are you have the full view of the ecosystem. Connect the dots back. The layers that we had in the stack, you can also expand that, and knowing about them is going to save you quite a lot of hassle. You do not necessarily have to use OpenTelemetry to do tracing, because those two are different. Even if the first server, the first reverse proxy at the edge just slams a UUID header that gets carried into the rest of the chain, that will at least allow you to look for logs with that UUID. And sure, this is going to be a tiny bit manual, but at least you will have the full logs. So do not wait until you implement OpenTelemetry to get a semblance of tracing. Notably, look at the W3C trace context specification. It's absolutely great. Remember that the cables usually do not do tracing. They are not going to tell you, oh yeah, I received this packet and I send it this way. So if you want to tell the network story, you probably want to have both peers reporting and telling you, hey, I sent this. Oh yes, I received this. Oh, there's a gap. that's your cable. So having more information here is going to be super important. I have like a few minutes. I just want to show you something. Varnish does OpenTelemetry. And this is a new tool called Grafana. I don't know if you know it. And it's using Tempo. This is just a Docker compose. It's a silly one. But the important part, oh no! I should have known. I shouldn't have clicked away. Give me a second. I should know better. Well, you know it's real now. Come on. I swear to God, it was working. And I have a few minutes, so we're good. Okay, search. Are we okay? No, we are not okay. It was so pretty. I swear. Okay, fine. Give me half a second. There we go. It was all planned for drama, believe me. Okay, so that guy. This is a very simple. This is a very simple setup. Our client is going to Varnish, and Varnish is going to use 2 different origins to do content composition, but it's also going to do a bunch of retries. So even though my infrastructure looks like this, if I look at the waterfall chart, it's quite messy because Varnish is going to try some stuff, do some backend requests, and it's going to tell you everything. And it's an overly complicated setup. But if you look at all the spans, yeah, Varnish is able to tell you about everything that happened. Most of them here are Varnish, only the leaves are the origins. But yeah, Varnish in its over verboseness allows us to get us pretty graphs, and yeah, that has to count for something. So yeah, just wanted to show you it exists, and I prefer that to a crappy server that's going to say, yeah, no, I got the request. I'm not going to tell you what happened in it. This trust that you will be able to handle the information. Okay, and with this, let's see if I can find my slides back. Yes, I can. Questions?